Today, we are cracking open the playbook of a penetration tester to really understand one of the most persistent and honestly powerful vulnerabilities on the web, SQL injection. This quote comes straight from security expert Joe McCrae, and it really just cuts to the chase. This is what penetration testers do. They think like an attacker. They find the ways in so you can figure out how to keep the real bad guys out.
It sounds completely absurd, doesn't it? I mean, 1 equals 1. That's always true. But that simple, undeniable piece of logic, that is the fundamental key that can unlock a website's most sensitive data. And we're going to show you exactly how.
Okay, so let's dive right into this first concept, because this is really the foundation for so many SQL injection attacks. It's all about tricking the database into thinking a statement is true, even when part of it is false. So look here on the left. This is how a login should work. The database needs the username and the password to be correct. Simple enough. But now look at the right. An attacker doesn't put in a real password. They just type the username admin, followed by a double dash. Now in SQL, that double dash means ignore everything after this. It's a comment. So the whole password check just gets ignored. The query now just asks the database, hey, does the user admin exist? And of course it does. And just like that, they're in. All right, so now that we get the basic trick, let's look at the 3 main ways an attacker uses these injections. It's not just about getting in, it's about pulling sensitive information out. Okay, first up is inbound. Think of this as asking the database a question and having the answer pop right up on the screen for you to see. It's the loudest, most obvious method, but when it works fast. And there are basically 2 flavors of this. You've got error-based, where you cleverly try to break something. You force an error message, but you do it in such a way that the error message itself actually contains the secret data you want. The other way is union-based. Here, you use a command called union to kind of stitch your malicious requests onto a normal one. The result? The data you were trying to steal gets attached to the legitimate results you see on the page. Now, the second type is way sneakier. It's called out-of-band. This is like telling the database, hey, don't show the secrets on the website. Instead, I want you to send them to this other server over here that I control. This is so much harder to detect because from the website's point of view, everything might look perfectly normal. And then there's this one, the cleverest of them all, blind injection. This is what you have to do when you can't see any data or error messages directly. It's like playing a game of 20 questions with the database. You ask a series of true or false questions, and you figure out the answer based on how the website behaves. It is incredibly slow, but unbelievably powerful. So, with all these different attack types in mind, what's the actual process a penetration tester goes through? Well, it's not random. Let's see how these pieces come together to form a repeatable strategy. It really is like a logical funnel. First, you gotta find a weak spot, an injection point. Then you figure out what kind of data you're working with. Are we talking numbers or text? From there, you always start with the easiest, loudest attack, error-based. See if you can get lucky. If that doesn't work, you move on to union-based, which is awesome for pulling out lots of data at once. And only if all of that fails, only then do you commit to the slow, painstaking process of a blind injection. It's your last resort. So let's zoom in on that last resort, on blind injection, because this just brilliantly shows how creative these attacks can get. You're literally weaponizing time itself. Okay, so check this out. Here's how it works. The attacker sends a query that basically asks, is the username 1 character long? If it is, I want you to wait 10 seconds before you respond. Well, the page loads instantly, so that's a no. Then they try again. Okay, is it 2 characters long? Nope, instant load again. Then they try, is the username 3 characters long? And suddenly, the page just hangs. It waits for 10 seconds before it finally loads. And bam! Just like that, without seeing a single piece of data, the attacker gets their first clue. They now know for sure that the username is 3 characters long, just by watching the clock. And from here, they can just repeat the process, 1 character at a time, until they've reconstructed the entire name. It's genius, really. So you might be thinking, couldn't a computer just automate all of this? And the answer is, well, yes and no. This is where the skill of a human penetration tester becomes absolutely crucial. Look, automated scanners are great. They're fantastic for finding the low-hanging fruit. But as Joe McCrae points out, they're usually just programmed to look for 1 or 2 specific types of injection, like those really obvious error-based ones we talked about first. They follow a script. And here's the critical part. Relying only on these tools can give you a really dangerous false sense of security. A scanner might come back and say, hey, this site is clean, all while a human expert, using intuition and creativity, could find a cleverly hidden blind SQL injection that the automated tool completely missed. And this brings us to the final level of this whole thing, the constant battle, this cat and mouse game, between attackers trying to slip past defenses and the security systems built to stop them. So a basic security system, right? It might be programmed to look for the exact phrase, or 1 equals 1. But an attacker is never going to be that obvious. They'll just use or 2 equals 2 instead. Same result. Or a math statement like or 1 less than 2, which is always true. They can even use weird comments to break up the attack string, making it totally invisible to a signature that's looking for a specific pattern. And this is the whole point. This constant evolution is why cybersecurity isn't about building one perfect, impenetrable wall. It's an endless game of adapting to an opponent who is always changing their tactics. So let's just boil this all down. What have we learned from peeking inside the hacker's playbook? First, a tiny, tiny flaw in logic can become a massive weapon. Second, attackers have this diverse set of tools, from loud and obvious to slow and silent. We've also seen that automated tools just aren't enough. And finally, that security is never done. It's a constant, never-ending process. Because seriously, behind every single login form, every search bar, every button you click, there's this incredibly complex system of data and queries. And understanding where the weaknesses could be, that is the absolute first step to making the web a safer place for all of us.